So far we have done hypothesis testing regarding proportions and then also means. In this chapter, we want to consider a different type of hypothesis test. We're going to test the entire probability distribution to see if it follows a set distribution. So for example here, we might want to test and see if the population's favorite color of M&Ms follows the candy maker's distribution, which is 24% blue, 20% orange, 16% green, 14% bright yellow, 13% red, and 13% brown. Now we need a new distribution to do this, and that distribution is called the chi-squared distribution. We will talk about that more a little bit later. So first we're going to consider what's called a multinomial experiment. That's what's going to generate this kind of data here. So in a multinomial experiment, you have n identical trials, so a fixed number of identical trials, k outcomes per trial, so the same number of outcomes per trial. So those could be classes or categories, or sometimes we'll refer to them as cells. And then we'll have probabilities of outcomes, P1, P2 up to Pk, and they have to be independent of the trial. And the sum, P1 plus P2 up to P sub k, has to equal 1. So in other words, those probabilities have to form a distribution, probability distribution. Number 4, trials must be independent. And then number 5, your random variables of interest are going to be the cell counts or the category counts, N1 through Nk in each of those k categories. So going back to our M&M example here, let's say that we test if Olivette's student's favorite color of M&Ms follows the candy maker's distribution, which we had above, 24%, 20, 16, 14, 13, and 13. And we're going to do that by examining the favorite color preference of M&Ms for each of 30 randomly chosen students. We want to know, is this a multinomial experiment? So do we have n identical trials? Yes, n will be 30. So 30 identical trials, that is 30 identical instructions given to the different students to choose their favorite colors of M&Ms. So that one checks out. K outcomes per trial. So the colors of M&Ms, we've got blue, orange, green, yellow, red, brown. There are only 6 colors. So there are 6 outcomes or colors. Per trial, so that checks out. Probabilities of the outcomes should be independent of the trial. So these probabilities that we end up with, the 24%, the 20%, 16%, those should be independent of which student you choose. So there should not be any relationship. So let's see, so the P sub i's independent of the trial. Number 4, trials should be independent. So picking one student, their outcome that they pick as their favorite color should have no effect on the outcome that the next student picks. So no student's favorite affects another. So we're not gonna allow, one person to say, hey, my favorite color is blue, pick blue for me. I really like blue. And then lastly, number 5, our random variables of interest are going to be the cell counts N1 to Nk of the K categories. So that's really not a condition so much as to just specify that our random variables here are going to be the number of blue, number of orange, all the way out to the last one will be the number of brown. So, and that's number out of the 30 total. So this is indeed a multinomial experiment. Now, how do we analyze it?